we looked into the domain of the first four operations, and I held off on the composition between the given functions we had for f of x and g of x. And now just looking into the domain of the compositions between those functions. And again, so we have for part E, okay, we're looking for the composition, or at least the domain of the composition, where we have f composed with g of x. And for what we have in this expression, okay, so I have, again, f of x is equal to 3 over x minus 1, g of x we have equal to x all over x plus 12. And now for f composed with g of x, if I write what I have, again, just in compact functional notation, so I'm looking at f of g of x. All right, so we have the output function to be along the lines of f of x. And again, for the output function f, again, we have f of whatever the input is going to be equal to 3 over the difference between the input and 1. So we have f of the input is equal to 3 over the input minus 1. Okay, so we have for the composition, now we have the input is g of x. Okay, so we have, right now we have 3 over g of x minus 1. And now we have the input function is going to be a fraction. And here, once I specify just what g of x is, so you have 3 of the over the input minus 1, and translating what I have for g of x. Okay, again, we had the variable expression. We have x all over x plus 12 minus 1. So here I have a bit of a complex fraction. So I have 3 all over, and again, g of x, we have x over x plus 12, and then we have minus 1. And to kind of clean up what I have in the fraction, so I can just multiply the numerator and denominator by the bottom part of the fraction that makes this whole thing into a complex fraction. So we have, again, we have 3 all over, and we have x over x plus 12 minus 1, and multiplying by 1 in the form of, again, this denominator divided by itself. Okay, so I have x plus 12 all over x plus 12. And for what we have in terms of following through, okay, all right, so in looking at the distributing, okay, so I have 3 times x plus 12. Now for what I have in the denominator portion, okay, think of like distributing x plus 12 all over the first term, where we have x over x plus 12. Now here x plus 12s are going to cancel out. So I'm just going to say for the first term, okay, x plus 12s will cancel. So I'm going to have x. And then we have minus 1 times all of x plus 12. So I'm going to be looking at distributing subtraction, or in this case, negative 1 over the binomial x plus 12. Okay, so just from a little bit of a visual standpoint, okay, so you're going to have, that'll be essentially kind of like x plus 12s going out, okay, at least with the first distribution. So I have the x, and I have minus all of x plus 12. And for what we have in following through, so I have 3 all over x plus 12. And we have x and negative 1 over x plus 12. So we have negative x and a minus 12. And if you notice, okay, we're going to have the x's are going to cancel each other. So we're going to have 3 over, or 3 times the quantity of x plus 12 all over negative 12. And you can technically simplify this ratio because we have 3 over negative 12, and 3 will go to negative 12 negative 4 times. And so we can just bring this down to x plus 12 over negative 4. Okay. All right. And so we have, as a simplified ratio, okay, we're going to have x plus 12 divided by negative 4, okay, to be the resulting composition. So you have x plus 12 over negative 4. Now, where the domain is concerned, okay, so for f composed with g of x, again, very tricky problem. Okay, again, for we have with g of x, that was x over x plus 12, and filling in, and again, doing a lot of cancellation and combining of terms, okay, and simplifying, we came down to this result. Now, for what we have in looking at the domain of this particular composition, so we have with the input, okay, and the input was g of x is equal to x over x plus 12. And for g of x, okay, there is a restriction, and it is that the denominator cannot be 0. And so, in this one, if x plus 12 cannot be 0, well, we have that x cannot be equal to negative 12. Okay. Now, we have, in the case of the output, in the case of the output, again, we have x plus 12 over negative 4. Now, the only place where we have the variable term to exist is in the numerator. Now, we do have a fraction, but we have a non-zero valued denominator. So the output in itself, this is going to have no restriction. And so just looking at what we have for this particular part, and just kind of looking at what we have, again, so we have this composition, f composed with g of x, and now the output, again, you don't have an even root radical, and even though we have a fraction, the fraction is fixed where the denominator is non-zero and will stay non-zero. So we have between the compositions, you have the input, whereupon the restriction is that x does not equal negative 12. And for what we have between the input function and the overall output, we will have that the only restriction is going to come from the input. So the only restriction is that x cannot be negative 12. And so for what we will have in the case of the domain, okay, so again, negative 12 is left out. Okay. And so we have at this location, okay, so we have a hole at negative 12, and then we have everything else in the domain. All right. So you have continuity on both sides here. All right. So for part 8, okay, so you have for the domain of this composition. Okay, so you have values of x less than negative 12, along with those values of x which will be greater than negative 12. So that'll be the answer to what we have in the case of part E. All right, and then we have with the remaining composition and still using the same functions. Okay, so we're looking for the domain of G composed with f of x. And again, so we have again, we have with the same functions. And now looking at G composed with f of x. Okay, and we have in the compact functional notation, so we have G of f of x. And now we have the output function, okay, in line with G of x. So this one we have G of x, or G of the input, is equal to the input all over the input plus 12. Okay. And so for what this is going to translate out to, okay, so you have the input again, so this is going to be f of x. We have all over f of x plus 12. And so we have for f of x, we have 3 over x minus 1. We have all over 3 over x minus 1 plus 12. Okay, so in one sense we have a bit of history to repeat, for we have another fraction. This time we have a ratio between fractions. And here we can get out of this notation if I multiply the top and bottom portions by 1 in the form of x minus 1 over itself. Okay, and so we have here, okay, so if I take multiplying by 1, again in the form of x minus 1 over itself. Now what's going to happen here is that for the top part, 3 over x minus 1 times x minus 1 is canceled, so we're going to have 3 on the top. And then for the denominator, okay, you have x minus 1 cancels, leaving us with 3. And as for 12, we have 12 times the quantity of x minus 1. And we have narrowing it down. Okay, so you have 3 over 3 plus 12x minus 12. And so we're going to have, in following through, we have 3 over, okay, we have 12x and 3 minus 12. This will be negative 9. So you have 3 over 12x minus 9. And also, I can simplify this ratio because 3 will go into 12x and negative 9. So for the simplified result, okay, we have 1 over 4x minus 3. Okay. Okay. And in terms of what we have regarding the domain of this composition, all right, so we have f of x is the input. And again, we have f of x is equal to 3 over x minus 1. So the input restriction is that x cannot be equal to 1. And for what we have in the case of the output, okay, now this time we have a fraction, and this time we have 4x, or a variable expression, in the denominator, which I did not have in the previous composition. Okay, so I have 1 over 4x minus 3. And for the restriction that we have on this one, okay, so we have that 4x minus 3 cannot be equal to 0. Okay, so we have 4x cannot be equal to 3. And so that means that left out, we're going to have a fraction excluded, okay, whereupon x cannot be equal to 3/4. So for what we have for the input function, and we have also included, we have with the output. So we have combining the restrictions. Okay, so you have two exclusions. Okay, whereupon we have that x cannot be 1, and also x cannot be equal to 3/4. Okay, and so looking at the dynamics that will play out. Okay, so we have you have a fraction at 3/4. Also, we have the number 1. Again, both 3/4 and 1 are excluded. All right, and bit of history repeating. Okay, so you have for each hole, okay, have activity to the left and to the right, and in the case of the domain. Now, before we had one exclusion, so you had two subintervals, okay, forming the domain, okay, or defining the domain. Now we have two exclusions, and there are going to be 3 subinterval sections. So for the domain of G composed with f of x, and we have those values x that will be less than 3/4, followed by those values greater than 3/4 and less than 1. And for the rest, okay, we have those values of x which will be greater than 1. All right. And so that will complete the first part in the test 2 review. Now, the other day when we looked into the second part, and we already looked at the domains, okay, of items 1 through 3, and now just picking up now again for number 4. Again, you have what is referred to as average rate of change, okay, and average rate of change, that's just the formal functional way of looking for the slope. And now for average rate of change, now we're looking at the average rate of change from x equals -1 to x is equal to 4, and we have given the function whereupon we have that f of x is equal to -3x squared plus 2x plus 1. Okay, and so we have just with the x values, so we have the initial points. Okay, we have an x is equal to -1. Okay, so your y value would be like y is equal to f of -1. So we have -3 times the square of -1 plus 2 times -1 plus 1. And so we have -3. -1 squared is +1. 2 times -1 is -2. Again, we have followed by 1. And for what we have in terms of the follow-through, okay, so you have -3 minus 2 plus 1. So you have -5 plus 1. So this will be at -4. Okay, so you're looking at the points on the graph of this function, whereupon when x is -1, we had that y is equal to -4. And for what we have for the second point, okay, we're looking at x is equal to 4. And so we have here, we had that y is equal to f of 4. So we have -3 times the square of 4 plus 2 times 4 plus 1. Okay, now 4 squared is 16. And we're going to multiply that by -3. Now for 2 times 4, okay, that is 8. And we have plus 1. And gathering, okay, so you have -48 plus 8 plus 1. Or by then you can say -48 plus 7. So this will come out to -48 plus 8 is -40 plus 1. So this will be a -39. And so for this particular ordered pair, okay, so we have x is at 4. And y comes out to -39. Okay, so you're looking at going from -1, -4 to 4, -39. Okay. Now again, the graph of this function is not going to be a straight line, but just looking for the average rate of change, connecting these two dots, okay, you are going to have a straight line. And now for the average rate of change, again, so that's going to be the slope of the secant line. In other words, the straight line that connects those 2 points of interest. And again, I can just put this in terms of just the general slope formula. Okay, so I have y of 2 minus y of 1 all over x of 2 minus x of 1. And keep in mind that all ordered pairs are of the form x and y. So with -1, -4, I can identify this as the first x and y values. And with 4, -39, I'll have this as the second set. So for y of 2 minus y of 1, so we have y of 2 is at -39. And we have subtracting y of 1. Y of 1 we have at -4. And for x02 minus x01, okay, so you have 4 minus negative 1. Okay, so you have negative 39 plus 4 all over 4 plus 1. And then for the change in y, okay, so we have negative 35 units. And for what we have for the change in x, we have 4 plus 1, which is 5. So the average rate of change, we have negative 35 over 5. And so that will come out to a negative 7. Okay. All right. So again, just the average rate of change. Okay, that's just another way of asking what exactly the slope is going to be. And now, just looking at what we have in the case of the next item. And we have for going from the average rate of change to what we have now. Let's see, yeah. So you're looking at whether the following functions are going to be odd or even or neither. Okay, and so for what we have here. Okay, so we have for the first function, we have f of x is equal to x times the absolute value of x plus 5x cubed. Now I'll just mention again for what we have in the case of an odd function. Remember, you're going to have opposite sign inputs will lead to opposite sign outputs. And in the case of what we have with even functions, opposite sign inputs will still lead to the same outputs. And for what we have, again, so we got with the case in number 5. Okay, so we have x times the absolute value of x plus 5x cubed. Okay, and see how these are going to line up. Okay, so testing out what I have for f of x. Okay, so you have x times the absolute value of x plus 5x cubed. Okay, and with x, say as a non-negative, absolute value is a non-negative. Now the absolute value of x is going to be x. So for f of x, you're looking at x times x plus 5x cubed and so for f of x, we're going to have x squared plus 5x cubed. All right. Now, for f of negative x. Now, this one, a little bit tricky. For f of negative x. Okay, so I'm replacing x with negative x. So you got negative x times the absolute value of negative x. And we have plus 5 times the cube of negative x. Again, now absolute value of negative x, okay, that's going to go to x. And now the cube of negative x, okay, this will go to negative x cubed. And for what we have in following through, okay, so you got negative x, and we're going to have times x, and we have plus 5, and we have times negative x cubed, and so for what we're going to have in the follow through, okay, so you have negative x times x, this is going to be negative x squared, and 5 times negative x cubed, we have a minus 5x cubed. And looking at how everything is going to line up. Now, in terms of the inputs, you have x and negative x. So these are going to be opposite each other. And for x squared plus 5x cubed, negative x squared minus 5x cubed. Okay, so you have for the first, you got x squared. For the second, you have negative x squared. So these are going to be opposite. And then for the second term, for f of x, you have positive 5x cubed. And then for f of negative x, we have the second term to be negative 5x cubed. So you also have to be opposite. Okay, so if we have opposite sign inputs lead to exclusively output terms that will be unanimously opposite throughout, this means that the function we have here is going to be one that is odd. So the result here for f of x equal to x times the absolute value of x plus 5x cubed, okay, that one is going to be an odd function. All right, now for what we have in 6, now we have 2 over x plus 3. And in this one case, you have g of x. Okay. Doesn't change the purpose, just different letter. Okay, so you have g of x is equal to 2 over x plus 3. All right. So for g of x, okay, we have just 2 over x plus 3. And for g of negative x, okay. And in this one, okay, so for g of negative x, okay, so you have 2 over negative x plus 3. Okay, and all right, and if you notice, okay, between g of x and g of negative x, okay, the inputs are opposite each other. Now, and if you notice, okay, we have just looking at the relation now, we have 2 over x plus 3 and 2 over negative x plus 3. So the outputs are not the same. Okay, and also for the outputs, now you're not going to have these to be additive inverses either. Okay, let me just mention. So the opposite of 2x plus 3. Okay. If you're looking at the additive inverse, so you have like negative 2 over x plus 3. But let's say if I kept the 2 positive and I shifted the weight of the negative over x plus 3. So this would be 2 over negative x minus 3. And if you notice, 2 over x plus 3 and 2 over negative x plus 3, those are not the same. And guess what? The opposite of 2 over x plus 3, we have 2 over negative x minus 3. Guess what? I don't have negative x minus 3. So in this case, the outputs are not opposite each other. Okay, so they're not the same, and the outputs are not opposite each other. So this means that in terms of whether the function is odd or even, it's going to follow that g over 2x plus 3. This is going to be a case of neither. And just, again, just as a bit of a visual reference. Again, if I had an odd function, I would have like negative 1, 1, and 1, negative 1, negative 2, 2, and 2, negative 2. So I don't have opposite sign outputs, nor do I have the same outputs whenever you have additive inverse inputs. And again, no symmetry with respect to the origin, and you don't have any symmetry with respect to the y-axis. Okay, so again, we have neither case to apply. Now, and what we have now concerning what we have with number 7. Okay, so you have h of x is equal to the cubic root of x cubed plus 5x. So for what we're going to have here with h of x, we have cubic root of x cubed plus 5x, and we have with h of negative x, so we have the cubic root. Okay, here we have of negative x raised to the third plus 5 times negative x Alright, okay, so you have the cubic root of minus x cubed minus 5x and now for negative x cubed minus 5x, if I factor out the negative, okay, so we got the negative of x cubed plus 5x, and so just taking out what I have here, so this will be the negative of the cubic root of x cubed plus 5x, and now just repeating. Okay, so for h of x, okay, we have the cubic root of x cubed plus 5x. Okay, so in the case of the inputs, again, those are going to be opposite. And in the case of the outputs, okay, so you can look at this as where we have a positive cubic root of x cubed plus 5x, and the other we have a negative. And since we have opposite signs here, it's going to result that for this function h of x equals the cubic root of x cubed plus 5x, okay, that is going to result not as an even function, but as an odd function. All right. Now, for what we have in the case of the next item, okay, and we have just in reference to the graph, and we have for the various components, okay, and it says here, okay, for the graph below, it says to determine the domain and the range, as well as the relative maxima and minima. Okay, now in terms of the domain, or the domain and the range, now again, the domain is going to be in reference to the x values. Okay, and so for the domain, okay, you're looking at your x values. Okay, so you have kind of like going continuously out toward negative infinity. And for this arrowhead too, this would be kind of slowly indicating that you had the shift going slowly to the right toward positive infinity. So we have now for the domain, so between negative and positive infinity. All right. Now for the range, now the range is going to be in reference to the y values. Okay. And if you notice, okay, we have the bottommost y value. It's going to be located over here. And if you notice, okay, we have for the upward pointing arrows, you're kind of heading out toward y is equal to infinity. And we have with this ordered pair, okay, so we got -1, -5. So we have from the range, so we're going from and including -5. So that's going to be your bottommost y value, and it is included. And then everything else, okay, is going to be above, and the arrowheads indicate that y is going to keep on increasing to where we have approaching infinity. So again, the domain you have between negative and positive infinity, going continuously between the left and the right. The range you have going continuously upward, starting from y is equal to -5. So you have this range. And in terms of where we have the relative maximum and minimum. Okay, now for what I have in the case of the relative maxima, or in this case we have the relative maximum, okay, and if you notice at this particular point for the relative maximum, okay, it's going to be this particular peak point. Okay, so you have it 2, 1. So the relative maximum is going to be at y is equal to 1. and the relative maximum is going to occur at x is equal to 2. And for what I have in the case of the relative minimum, or minima, okay, you're going to have your relative bottom points. We have decrease followed by an increase. So for your relative minimum, okay, so you have y at -5. And also you have another dipping point where we have at y is equal to -2. And where the relative minima are going to occur, you're going to have an x equal to -1. And where we have the other relative minimum to occur, that's going to be at x is equal to 4. That's how we got to y is equal to -2. So you have, again, so the relative minimum, you have x is equal to -1 and also at 4. Okay. All right. So again, you have the domain to be the set of all real numbers. The range will be the set of values y greater than or equal to -5. And again, you have your relative maximum, okay, which again is going to be this particular point, which we have at 2, 1. And your relative minimum, again, we have at -1, -5, and 4, -2. The minima values we have in y, where they occur, those are going to be the corresponding x coordinates. All right, and where the intervals will be strictly increasing as well as decreasing. All right, so we have in the graph, again, you're looking at the intervals in terms of what we have in the variable x. Okay, and so we have in the stretch, okay, if you notice, okay, from reading in order from left to right. Okay, so this part we have a decrease, and then going past the first of the two relative minima, we have an increase, followed by a decrease, and then for the rest of the activity we have an increase. All right, so in the case of the intervals of increase and decrease, for the intervals of increase, again, the intervals, you're going to have only the parentheses as the grouping symbols, okay, because you're looking at motion. And where we have increase, okay, so you have going past x at -1, approaching but not including x at 2. Again, so you're going from x at -1 approaching x at 2. And then for the second and last increase, you have going past x at 4, and you have moving continuously out toward infinity. And for what we have in the case of the decrease, okay, so this is the first bit of motion as you read in order from left to right. So looking at your x values, okay, so you have going from x at -infinity, and you have approaching -1, and for the second and final decrease, you have going past x at 2 and approaching x at 4. Okay, so again, the increase you have between these values of x, -1 and 2, and also you have going past 4 and proceeding out to infinity, and the decrease you have between -infinity and -1, and then we have between x at 2 and x at 4. And again, the parentheses are the only grouping symbols we use for increase and decrease intervals. All right. Now, in looking at what we have for the set of items, and we have with our four given functions. Okay, so we have for f of x, g of x, h of x, and k of x. And now for what we have in the case of number 8. Okay, so we have, we're looking at g plus h of 5. For g plus h of 5. Okay, now we got the sum function with a specified input value. So again, we have g plus h of 5, and this would translate out to g of 5 plus h of 5. And we can go ahead and specify the values. So with g of 5, so you have g of 5. Okay, so you have g of x equal to x minus 7. And with g of 5 is equal to 5 minus 7. So that'll be at negative 2. And for h of 5, okay, so you have h of x is equal to x squared plus 5. So for h of 5, okay, so we have 5 squared plus 5. 5 squared is 25. And 25 plus 5 is equal to 30. Okay. And so with the inputs specified, so g of 5 at negative 2. And we have plus h of 5 at 30. And so we'll have negative 2 plus 30. And so we have for that result, this will come out to 28. Okay. Now for number 9, okay, we're now looking at h minus g of 7. Okay, and so for what we have in the case of h minus g of 7, okay, so we have h of 7 minus g of 7. Okay, and looking at what the input values are going to be. So we have, again, for h of x, you have x squared plus 5. And with x at 7, so we're going to have 7 squared plus 5. Okay, so we have 7 squared is 49. And adding 5, so we have 49 plus 5 is going to be 54. And in the case of what we have with g of 7, again, g of x is equal to x minus 7. So g of 7 is equal to 7 minus 7, which will be 0. And so we have with h of 7 minus g of 7, so we have 54 minus 0. And so we have for this output, okay, this will end up at 54. All right. Now, for what we have in the case of number 10, so we have g times h whenever x is at 5. So for g times h of 5, so we're still using the functions g and h. Okay, so for g of 5 times h of 5. Okay, so you have g of 5 equal to, once again, so you have for g of 5, okay, you have 5 minus 7. So you have at -2. And for h of 5, okay, we have that bit of history to repeat. So again, h of x is equal to x squared plus x, in this case, or plus 5 rather. Okay, so for g of 5, okay, so you have -2. And h of 5 we have at 30. And for -2 times 30, so we have for this result, okay, we have that to come out to -60. Okay, now, and looking at what we have for the next portion, so we're now looking at the involvement of the function f. There we go. Okay, so for f over g of 2, okay, so that's going to be equal to f of 2 over g of 2. Okay, so specifying f of 2. Okay, so we're now referencing f of x. Okay, so f of x equal to 3 over x plus 4, and with x at 2. So you have 3 over 2 plus 4, which we have at 3 over 6. And 3 over 6, that is reducible to 1/2. In the case of what we have with g of 2, for g of 2, okay, so you have g of 2 is equal to 2 minus 7. And we have 2 minus 7 is equal to -5. And just putting in what we have now, so we have 1/2 from f of 2. And for g of 2, again, I have -5. And just for the view here, okay, so we have, you can see, have 1/2. I'll just stretch this on out a bit. Okay, so you have 1/2 divided by -5. And in the follow through, okay, so if I divide by a number, it's the same as multiplying by the number's reciprocal. And the reciprocal of -5 is going to be -1/5. And so we're going to have 1/2 of -1/5. Positive times the negative is a negative. 1/2 of 1/5 is going to be 1/10. So for this composition, at x is equal to 2, the result we have at -1/10. All right. Now, for what we have in 12, now we have g over k of 0. Okay, so we're now involving the function k. Okay, so we're looking at g of 0 over k of 0. Okay, so we have with g of 0, we have 0 minus 7, which is -7, and for k of 0, we're looking at adopting k of x is equal to the square root of x plus 9. and here. Okay, so you have the square root of 9, and in reduction, the square root of 9 is only equal to 3. So you got g of 0. Okay, so you have it -7. And k of 0 is equal to 3. And so for the output, okay, we just have -7/3. And you can just leave that as -7/3. Right. Now, for what we have in the case of number 13, okay, so we're looking at composition of functions f and g, okay, where the value of the input x is at 3. So we have in this one, okay. So we have with 13, okay, so you have f composed with g of 3. Oops. Okay, now the output function I have in line with f of x. And again, just for f of x, or f of the input, we have 3 over the input plus 4. Now for f of g of 3, so I'm looking at 3 all over g of 3 plus 4. Okay, now I want to specify just what g of 3 is going to be. So for g of 3, and referencing g of x, okay, so g of 3 is equal to 3 minus 7, which will be -4. So we're now looking at 3 over -4 plus 4. And guess what? We got 3 at the top. -4 plus 4 is 0. And again, for a fraction to be defined, the denominator cannot be 0. And since I got 0 on the bottom, okay, this composition is going to be undefined. Okay. Now, reversing the order of the functions. Okay, so we're now looking at g of f of 3. Okay, so for g of f of 3, okay, so we have with our output function in accordance with g of x, okay, so we have x minus 7. Okay, so for g of f of 3, so for g of f of 3, so this is going to be f of 3 minus 7. And looking at what we have for f of 3, okay, so for f of 3, again, we have with our function f of x, so you have f of x equal to 3 over x plus 4. Okay, so f of 3 is equal to 3 over 3 plus 4, so this will come out to 3/7. And for what we have in following through, okay, so you have 3/7 minus 7 All right, so you have 3/7. Now for 7 as a fraction, 7 over 1 would be the same as 49 over 9. Okay, that 49 over 7. Okay, so you got 3/7 minus 49/7. So for that particular output, this will be negative 46/7. All right. Now, for what we have in the case of the operations, okay, so now we have, let's see. All right, so looking into what we have with domain. So for what we have with f composed with h of x, okay, so we have with our input at h of x, so we have with f of h of x, so we'll operate in line with f of x. So f of x, we have a 3 over x plus 4. And here we have f of the input is equal to 3 over the input plus 4. And just crossing over, so you have with h of x. So h of x, we have x squared plus 5. Followed by the addition of 4. And so we have with the final output case, you have 3 over x squared plus 9. Okay, so we have, in the case of the input, looking for the domain, so your input function, we have at h of x. So we have h of x is equal to x squared plus 5. And again, since this is a direct expression, okay, there is no restriction. And for what we have in the case of the output, okay, so you have 3 over x squared plus 9. Now the restriction is going to be that x squared plus 9 cannot be 0. But guess what? If I set x squared equal to negative 9, and we have like the exclusions be plus and minus 3i. So for what this is going to mean is that we're not working with the complex number system anymore. So you have no real exclusions. So that means for the output, there's no restriction. So between the input function and what we have with the output function. We have no restriction at all. And so that means that for 15, okay, we have the domain to be the set of all real numbers. All right, now for what we have in the case of 16, okay, so you have for g of k of x. Again, we have with our output function, okay, so you have g of x okay, we have equal to x minus 7. So g of k of x, okay, we have at k of x minus 7. And filling in, so k of x, we have the square root of x plus 9. Followed by the subtraction of 7. So that will be your final output. Now, for the input, okay, so you have k of x is equal to the square root of x plus 9. Okay, now the square root of x plus 9, now x plus 9 can be 0 or positive, so the restriction is going to be that x is greater than or equal to negative 9. And for the whole output, the only restriction is going to come from the square root of x plus 9. So that restriction is going to be the same. So you have x is greater than or equal to negative 9. So for this composition, so you have for the only restriction, we're going to have that x is greater than or equal to negative 9. And so we're going to have for the domain, you're going from and including negative 9 and then running continuously out to infinity. All right. And then with the functions f and k tied in together, okay, so you have for f of x, again we have 3 over x plus 4. And k of x, okay, we have the square root of x plus 9. Okay, now for what we have in the case of f of x and k of x, now your restriction, okay, we have the x cannot be negative 4. And for k of x, you're going to have that x is greater than or equal to negative 9. And for what we have in the case of 17, so for f plus k of x, okay, so we have it that x cannot be negative 4 to keep f defined, and to keep k defined, x has to be greater than or equal to negative 9. So just taking what we have here, so you have, think of it visually like a solid point on negative 9, and a whole at -4. And just with the activity. And it's going to follow that with the domain of this particular sum function. Okay, so we're starting from and including -9, approaching but not including -4. So you have a parenthesis. And then we have going past -4 and heading continuously on out to infinity. And so for what we have in the case of the next item, we have for f over k of x, okay, so for f of x over k of x, so 3 over x plus 4. And for k of x, again, I have the square root of x plus 9. Okay, so what's going to happen here is that you're going to have, I'm going to try to lump this together. X cannot be -4. And this for the square root of x plus 9. Now x plus 9 cannot be negative, and now it cannot be 0. So you're now going to have that x is greater than -9, and just to kind of lump it together, x is going to be greater than -9, -4 is not included, and we have for the domain. So we have going past -9, approaching but not including -4. And then we have going past -4 and going all the way out to infinity.